Hey, this is Mr. Ward, and welcome to the Geometry Do Now 24.1 video key. So, a reminder that if you have a line that's perpendicular to a plane, it's also perpendicular to every line in the plane that passes through its foot, and the foot is just the point where that line intersects the plane. So we have this really funky figure here, and we're asked to prove that angle PAR is congruent to angle PBR. We've been given that PR is perpendicular to plane M, and we've also been told PAB and PBA as angles are congruent, which doesn't seem like it has a lot to do with figuring out if PBR and PAR are congruent as angles. So, but it'll turn out that it has everything to do with it. So let's work things out a little bit. So we're supposed to prove that angle PAR and PBR are congruent. There are two triangles we could prove are congruent that would allow us to do that with Kappa-Kadaka. So what triangles would be useful to prove are congruent to get PAR and PBR being congruent? Well, that would be actually triangles, PAR and PBR, would allow us to prove angles, PAR and PBR by Kappa-Kadaka if we could prove the triangles are congruent. Okay, so we can already prove that one side of those two triangles is congruent because it's the same thing. They share PR. So we've already got that. Okay. But let's take a look at some other information. So that's actually one side, right? And that could be useful. So what does being angle PAB and PBA force to be congruent? What segments would that force to be congruent? Well, that means these are base angles that are congruent of a triangle, which makes this as an isosceles triangle. PAB is isosceles, and the sides that are opposite those angles, PA and PB, are going to be congruent. And so now we've got this side and this side being congruent. So we can say PA is congruent to PB because the congruent base angles of the triangles of the triangle, triangle PAB defines PAB as isosceles, and PA and PB are opposite those congruent base angles. Okay. Boop. And there we go. All right, so now we have a couple of pieces of information. We've got this side and this side here congruent, and it'll be pretty easy to also say that PR is congruent to itself. Okay, so we can easily prove that PR is congruent to itself with the reflexive property. I'm going to go ahead and do that again. So PR is congruent to itself by reflexive property, and we can say that PA and PB are congruent because of an isosceles triangle. Now, what two angles would now allow us to prove? So it's going to be really hard to prove just BR and AR congruent without some other stuff. Eventually, we'll be able to prove that. But we have a side and we have a side. So I don't think we're going to do side, side, side right now. We do have two sides. What angle would allow us to use the side angle side? Or what angle should I say would allow us to use side angle side to prove that triangle PAR and PBR are congruent? Well, it's this angle right here. BPR and APR would do the job. So angles BPR and APR would do the trick. Okay, and well, we don't have enough information yet to say that they are congruent, but maybe if we could prove the triangle PQB and PQA are congruent. So if we could do that, then we could prove our last piece. I'm just going to label some things. So we know that and that. And we also know this. All right. Well, remember back at the very beginning of this, I made a note that PR is perpendicular to M. Well, what kind of triangles? I'm asking you, what kind of triangles are PQB and PQA? Well, if PR is perpendicular to plane M, then it's perpendicular to QB and QA. And that would mean that PQB and PQA are right triangles. They are right triangles because PQ is perpendicular to BQ and AQ. All right, so that gets us a little closer. Since they are right triangles, then the hypotenuse leg idea comes into play. Okay, so not only is PR congruent to itself, but so is PQ. PQ is congruent to itself. And we know also that this side and this side is congruent. And we know this. We know this is a right angle because those are both right triangles because PR is perpendicular to BQ and BA, or AQ and BQ. Okay, now because of that, the hypotenuse leg comes into play because these hypotenuses and this leg of these right triangles are congruent. So, since they're right triangles, what information will allow us to use the hypotenuse leg? Well, the hypotenuses. Okay, so AP being congruent to BP, hypotenuses, and PQ being congruent to PQ because of reflexive. It gives us a leg. Okay. Now that we have all of that, we're going to be able to ultimately prove the last bit. So I'm just going to label that a little bit. So we are going to know that this angle here is congruent to this angle here as well. All right, so now 1F. How do we know that angle RPB is congruent to angle? Now, how do we know that? Well, we know that simply because that's the same angle as well, we know it because of Kappa-Kadika. Actually, I jumped a gun here earlier. I leave that out for a second, but because we can prove that these two triangles are congruent by hypotenuse leg, we can now say that these angles, which were RPB, and RPA, we can prove they're congruent because these two angles happen to be corresponding parts of congruent triangles. And so then we now have side angle side that'll allow us to prove that the triangles PAR and PBR are congruent. So side angle side allows us to say triangles PAR and PBR are congruent. And then Kappa-Kadika allows us to say that angles PAR and PBR are congruent. All right, I hope that helped. And I'm sorry about the little windy trip there at the very end. I am tired, but we'll talk about it in class as needs be.